Okay, so when you are dividing fractions, you may have come across this thing at school where they tell you to cross multiply. And what that actually looks like is, imagine you've got two fractions, okay? So you've got maybe 4 divided by 2 is 1, and you've been asked to divide it by, let's say, 2 over 5. And what you are told to do is to multiply the numerator here by the denominator here, and then you're then asked to multiply the numerator here by the denominator here. And you might be thinking, how does that work? So I wanted to make this video just because when I was at school, no one actually ever explained this to me, and it is actually really simple. And what we're going to do is we're going to actually simplify the problem. Okay, so imagine we've got 4 boxes. All right, imagine we've got 4 boxes, and instead of doing this whole thing all at once, we're going to imagine that our problem is simpler. Okay, and what we're going to do is we're going to first say, imagine we've just got 4, so we'll ignore this part, and then we're also going to make this simpler, and we're going to say, what is 4 divided by 1/5? All right, what is 4 if we see how many fifths we can fit into it? Now, what is 4? Well, 4 is 1 4 times, right? 4 is 1 4 times. The number 4 just means 4 lots of 1. And that's obvious, but how many fifths go into 1? Well, if you have 5 fifths, you have 5 over 5, right? So 5 over 5 is the same as this. It's the same as 1, right? This is the same, right? You've got 5 units of 1, and you split them into 5 bits, you've got 1, okay? So what we're going to do is we're going to say, okay, well, if 5 fifths fit into 1, how many fifths fit into 4? And we can represent this visually. What we'll do is we'll go, okay, we'll take each box and we'll divide it into 5 parts, and then we're just going to count the parts in it, right? So this is really simple. It's going to be slightly tedious and boring watching me draw this, but just bear with me. Okay. Well, I should have probably drawn this a little bit neater, but never mind. And then we're just going to count. Okay, 1, 2, 3, 4, 5. Okay, this shouldn't be a surprise, right? 5 fifths go into 1 box, and then we continue here. And it's another 5 fifths, which takes us up to 10 fifths. And then it's 11, 12, 13, 14, 15. So I'll just make these slightly bigger. 5, 10, 15, 5, 10 over 5. That's 5 over 5. So far we're at 3, and then it's 16, 17, 18, 19, 20. Okay, so 20 over 5, and that equals 4, right? If you divide 20 by 5, you get 4. And what we've done is we've just done this, and we've discovered that it equals 20, right? And you might be thinking, well, why is this useful, Luke? Why are you telling me this? And the reason why I'm telling you this is because this kind of makes sense, right? Like, we took a fifth and we saw how many times it fits into 4, and we got 20. And then we've got to think about this in another way, because actually if we do this whole thing now, well, when we do this, what is it we're doing? Well, we're doing the same thing again, right? But instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, we're taking steps of 2, right? We're not dividing it by 1/5. We're not dividing 4 by 0.2. we're dividing 4 by 2/5, or we're dividing 4 by 0.4. So we're going to take steps of 2, and if we do that, what we get is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? Instead of taking 10 steps, we took 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So we took 10 steps in total. And this should make sense because we're dividing 4 by 2/5 this time, right? So if 4 divided by 1/5 was 20, 4 divided by 2/5 will be 10, because we're dividing this by a bigger number. Now, actually, we didn't have 4 if we look at our original problem. We had 4 split into 2 parts. So actually, the reason why you can cross multiply is because what you start off by doing is you see how many fifths, how many of the smallest of whatever this is, right? So we know we're working in fifths. We're going to do 1/5. How many fifths fit into that number? And then we multiply these because this number here indicates how much bigger the jumps are. Yeah, instead of doing fifths, we're doing 2/5. So the jumps are twice as big. And then this actually indicates how many parts we have to divide this into. So we end up being able to say, okay, well, we know that this is a fifth and it will go into 4 20 times. Okay, so that's the first bit that we do. That's where this comes from. It's basically saying a fifth goes into 4 20 times. And then we say, okay, well, actually, we wanted to make jumps of 2. So we're not just looking at that, we're looking at jumps of 2. So that would actually bring this down to 10. And then we also need to discard half of this 4. So this then becomes 2 times 2, which is 20 over 4, which is 5. Now we might want to check that this is correct, right? So we've got 20 over 4. We have 20 over 4. And we think that it equals 5. And what our original question was 4 over 2. And that is equal to 2. And 2 over 5 is equal to 0.4. And how many times can you put 0.4 into 2? Well, how many times can it go? So let's just keep adding this up. Okay. Sorry, dropping my phone there. And then we'll just count these. So 1, 2, 3, 4, 5. And this is essentially why cross multiplication works. Okay, you're just simplifying this problem. You're starting out by doing that, and then you are, making it bigger. You're counting for how much bigger what we actually did in reality was, and you're also making this smaller. So we weren't doing 4 divided by a fifth. We were doing the equivalent of 4 divided by 4/5, and that gives you 5. And then when you get your answer, remember that you can always work backwards from this. Okay, so you can check your answer by going through here. And the thing is, cross multiplication, it will work for anything you want to do, right? So you could do another one quickly, and let's just say we've got a quarter, right? And we are going to divide it by this, which is actually 3/4, right? You can do cross multiplication. You're saying, okay, well, how many 16ths go into 1? And in that case, it's 16. And then you can say, how many times do I need to make this basically bigger? Because I'm not dividing 1 by 1/16. I'm dividing it by 12 times that amount. And I actually don't have 1. I've only got a quarter of 1. So you end up with this, right? And if you notice closely here, not only is this divisible by 2, which means that you can actually do halving it till you get your answer, till you get your right answer. But the whole thing is actually divisible by 16. So you could have gone straight to the answer that we're going to get. But I'll show you this, because whenever you've got two evens, you can keep on making them smaller, and you've got a third. Okay. If you want to get back to this, you can say, okay, I've got a third. I know I've got a third, and I want to check that that is indeed 16 over 48. I'm going to need to multiply this. Okay, I'm going to need to multiply this by something equivalent to 1 that gives me the same answer as that, right? And it will actually be this, okay? It will be 16 over 16. Why? Well, because any number times 1 is itself. So 16 over 16 is 1, okay? And that will actually give us 16 over 48. This and this are the same thing, right? That's why we can use an equal. And 16 over 16 is 1. It's the same thing. 8 over 8 is 1. 4 over 4 is 1. Any number divided by itself is 1. And this is why cross multiplication works. It's literally just starting by simplifying the problem and saying what small amount fits in here. And okay, I actually know that I wasn't trying to fit this very, very small amount in here. I was trying to fit in some bigger amount. So what does that look like? Which we then did here. And then we said, well, actually, this wasn't true either, because what we were actually doing was this. Okay? Which equals 5. Which is the same answer we got when we cross multiplied everything out. And this is the intuition of why cross multiplying works. You know, you are basically saying, if we imagine this problem is simpler, and we just put a fifth into here, and then we're going to make whatever answer we get, we're going to divide it by how much bigger this actually was times how much smaller this actually was, right? Because we need to shrink this. We've done something very simple, and then we need to shrink this by some amount, and at the same time increase this by some amount. And you end up with being able to cross multiply like this, and it's essentially the same thing as step number 1 here, where we simplify the problem, step number 2, where we add back in how much bigger this actually was, and step number 3, where we say, okay, now we've done that, what we actually want to do is factor in how much smaller this was as well, right? So it's the same as saying, you know, we had 20, but actually what we were doing is we weren't dividing it by, you know, bars of 1. We were dividing it into steps of 2, but then actually only half of them mattered, right? So, you know, you've got a reduction here because you've only got half the number, and then you weren't just looking at fifths slotting into it, you were looking at 2/5. And that's the whole process of it. That's what you are told at school when they tell you to cross multiply, that this is what you are doing. And you can think of it as taking these boxes and then dividing it up and then increasing your steps and then eliminating boxes.
to give you your true answer. And that's why cross multiplying works.